Okay, we're going to take a look at related rates. And this is in 4.6 in your textbook. So we're going to be given a rate at an instant in time, because remember, calculus is instantaneous rates of change. So we're given an instant rate of change, and then we're going to relate it to a formula that's tying the question together and find a missing rate at that instant. So we want to think about all the variables are varying with respect to time. So this means something is a constant or a variable if it changes over time. And if it changes over time, it is a function of time. So we're going to use that implicit differentiation this time, only instead of with respect to x, it's going to be with respect to time, because it's happening in real time. So what you want to do is you want to think of these related rate word problems as a video that we're pausing, and in that instant that we pause it, that's when we're calculating the math. So to separate out constants from variables, you need to think about when the movie is playing, is it varying? If so, then it's a variable. Is it a constant when the movie is playing? Then it is a constant. So it's not when I pause the video, because once I pause the video, everything becomes a constant. So you really have to think about this. Okay, so I'm going to give you a little example just to get us started in this first video. Okay, so let's say that we have a circle. We could spill some water and then the circle is just spilling out. So we'll keep it really simple for this first question. So we have a circle, and imagine in the video, it's getting bigger as it spreads out. Okay, so the arrows are sort of showing its movement. And as that area is getting bigger, so is the radius. So there's an area that is increasing and a radius that's increasing. So both of these over time are getting larger. So we say that they are functions of time. So I'm just going to write that down. So the area and radius are functions of time. Okay, so a formula that links those together would be area equals pi r squared. So this is the area being linked to the radius. They're both variables of time, so I'm going to implicitly differentiate with respect to time. Okay, and I'm just going to show you what this does without all the trappings of a whole word problem, which we'll do in the next video. So if I implicitly differentiate both sides, knowing that a is a function of time and r is a function of time, then I would get the derivative of a is just 1 times dA dt. So that is the derivative of a with respect to t, equals, and then I have 2 pi r times dr dt. So every time I take the derivative of a variable, hidden inside it is some function of time. So I evoke the chain rule and have to multiply it by dr dt or dA dt. Now what this does is it allows me to relate that rate to this rate. So if I knew some information, like for example, if I knew the rate at which the radius was changing, I could find out the rate at which the area was changing. So that's what we're going to look at with these word problems. So hopefully that was helpful.